All right, good morning again, Mr. Coogan here. Yesterday you guys solved systems of equations using substitution when you were just given a solo number. So you were already given one of the coordinates for your answer. Today you're being given a term, okay? So you have a coefficient and a variable. The process is the exact same, except now you're going to have to do a little bit more work when you substitute because I'm not being given one of these coordinates. So I have to find both of them today. Now if you look here, I have y equals 3x plus 14 and y equals negative 4x. So because I have a y equals all of this stuff, I have to substitute all this in for my y. I can only substitute it in for wherever my variable tells me to substitute it in for. So I'm going to take this negative 4x and I'm going to put it in for y. Negative 4x equals 3x plus 14. Now, this is a sort of two-step equation here, so I'm going to separate my two sides of the equation, and I'm going to get my x's together on one side and just my whole numbers on the other. So in order to do that, I need to move this 3x using inverse operations. The inverse of a positive 3x is a negative 3x, so I'm going to subtract 3x on both sides. 3x minus 3x cancels out. Negative 4x minus 3x equals negative 7x equals 14. So now I have a one-step equation to solve for x. So again, I'm going to separate, and the inverse of negative 7 times x would be division. So I'm going to divide both sides by negative 7. Negative 7 divided by negative 7 cancels out to be 1. That leaves me with x equals negative 2. So I can put that in my answer here, x equals negative 2. Alright, so I found my x coordinate, I have to find my y coordinate now. So what I'm going to do is I'm going to take this x equals negative 2 and I'm going to plug it in for either one of these equations. It doesn't matter which one you use, you'll get the same answer. So I always use the shorter equation. So I'm going to take this negative 2 and plug it in for x. So y equals negative 4. Instead of x, I'm going to put in my negative 2, and that equals 8. So I can take this 8, put it up here, and I have one solution, and that's the one solution. Okay? Now, we have another question here on number 4 on the back of your worksheet. So this is the let's do this problem. This is number 4 on the back. And what's different here is for this first equation, I'm given two equations that both start with y. For this one, I'm only being given one. So in order to solve a system, I have to make sure that I have one variable, at least one variable by itself. And I do. I have a y equals 2x. So for this equation, I'm just going to solve it like we did yesterday. I'm going to take this 2x and plug it in for y. So I have x plus, instead of y, I'm going to put 2x and bring down my 9. So I have x equals x plus 2x. I can combine that and get 3x equals 9, and I have a one-step equation. So separate. This says 3 times x, so the inverse would be divide. Both sides by 3. That cancels to be 1, so I have 1x equals 3. So again, my solution is one solution. My x equals 3. I have to plug it in to find my y. I can use either equation. This top one is shorter, no negatives. I'm going to put it in there. Y equals 2. Instead of x, I'm going to put my 3 in. 2 times 3 equals 6. So that's how you solve a system of equations when you're being given a term instead of just a whole number.